Good evening. Today we will introduce about the material used in cycling mountain bike. Before we start our presentation, let me introduce our group. I'm Kong Kyun and my group members are Jishen and Elson. Now I will introduce the mountain bike frame. So basically, a mountain bike frame is the main structural component of the bicycle. It holds the rider's weight and connects all the mechanical parts together, which determines the overall stability of the bike. Compared to the road bikes, mountain bikes are used on rough and uneven road. As a result, the frame experiences strong impacts, vibration, and repeated loading. This means that the material used for the frame must be carefully selected to ensure safety, performance, and durability over time. Aluminum alloys, steel, and carbon fiber are the common materials of the mountain bike frame, each offering different advantages depending on the required properties. For this project, we identify 5 key material properties that are essential for a mountain bike frame. The first one is density. Density affects the total weight of the frame. A lower density material makes the bike lighter and easier to control, especially during climbing and long distance riding. The second property is tensile strength. This determines how much force the material can withstand before breaking. A high tensile strength is important because mountain bikes face impacts, bumps, and stretch from uneven trails. Next is ductility, which refers to the material's ability to deform without breaking suddenly. A ductile material can absorb impact energy, making the frame safer in case of crashes or heavy shocks. The fourth property is the modulus of elasticity, also known as stiffness. This influences how the bike feels during riding. The higher modulus provides a more responsive frame with better power transfer, while a lower modulus allows more flex and comfort. Finally, corrosion resistance is important because mountain bikes are exposed to rain, mud, humidity, and sweat. A material with good corrosion resistance will maintain performance longer and reduce maintenance needs. In summary, these 5 properties, which are the density, tensile strength, ductility, stiffness, and corrosion resistance, are necessary to ensure that a mountain bike frame is lightweight, strong, durable, and reliable in harsh cycling conditions. That's all for me. Now I will pass it to Jisheng.
Okay, thank you, Kongkyun. Now I would like to present about the material selection. The T800H carbon fiber composite has the lowest density at 1.81 gram per centimeter cube compared to the other two materials. It also has the highest tensile strength at 5,490 megapascal, meaning it requires a much heavier load to cause fracture. In addition, among the 3 materials, T800H carbon fiber composites has the highest modulus of elasticity when the load is parallel to fiber direction, indicating that it is the stiffest. However, it has the lowest ductility with only 1.9% elongation. Both Ti6Al4V titanium and 6061 T6 aluminum show moderate ductility, though their elongation value differs slightly, with titanium at 14% and aluminum at 17%. In terms of corrosion resistance, titanium performs the best, followed by T800H carbon fiber composite, while aluminum has the weakest resistance among the 3. Though all still offer acceptable corrosion performance. Overall, we decide to use the T800H carbon fiber composite because it combines low density, high tensile strength, high stiffness, and good corrosion resistance. Although it has the lowest ductility, its exceptionally high tensile strength means it can withstand a large load before fracturing. Okay, that's all from this part. Then Elson will continue the presentation.
All right, thank you, Jisheng. And now I'll be talking about the long-term sustainability and socioeconomic considerations of three materials that we evaluated. That is TA800H, carbon fiber, CFRP, and aluminum, and titanium. Even though performance is important for sports equipment, it's equally crucial for us to understand the environmental impact. And first, look at the energy use of CFRP. Among the three materials, carbon fiber has the highest embodied energy during manufacturing. This is mainly because producing the PAN-based precursor and carbonizing requires extremely high temperature, which leads to high CO2 emissions. Aluminum also has a high environmental cost when it is produced, but when it is recycled, it reduces up to 95%, meaning that it only uses only 5% of that energy. This makes recycled aluminum one of the most sustainable materials in the industry. Next. And titanium, on the other hand, is also very energy intensive due to the Crowe process. However, titanium frames tends to last decades, which helps spread out the impact over a long service life. Next, we'll be talking about the recyclability. This is where aluminum clearly performs the best. Aluminum has a well-established global recycling infrastructure, and therefore it can be repeatedly recycled with minimal loss of property degradation. This means that at the end of its life, aluminum frame can be reintroduced to new materials easily. And next. CFRP, however, is the least recyclable out of three, while it has recycling techniques like pyrolysis and solvolysis, but those are costly and not widely adopted. And as a result, most CFRP components often end up in landfills or incineration. Now, titanium, the recycling infrastructure of titanium is still highly unorganized and highly undeveloped, and therefore you could say that it's technically unrecyclable, but still titanium's, as mentioned, has extremely long lifespan, and meaning that the frequency of disposal is low, which reduces its long-term impact. Next. And now let's look at the socioeconomic factors. Aluminum, again, clears the other three, is the most affordable material, which means it supports mass market. Carbon fiber is significantly more expensive due to high raw material and production cost. And titanium frames is also highly expensive due to labor-intensive processes. Next. Maintenance-wise, aluminum still lead because it's easily weldable and repairable. And carbon fiber requires much more maintenance than aluminum do because it requires highly specialized technology. And titanium frames, on the other hand, resist corrosion well, so it requires very little maintenance. And that concludes the long-term sustainability part. And now I'll pass it over to Jisheng.
Okay, thank you, Elson. And now I will do the conclusion for our presentation. As for conclusion, the material we finally decided to use is T800H carbon fiber reinforced polymer. This is because it has most of the properties we desire, including low density, high tensile strength, high modulus of elasticity, and high corrosion resistance as compared to other two materials. However, it is less sustainability due to high consumption of energy during production. And it is also expensive in recycling, manufacture, and maintenance. On the positive side, this material requires less frequent recycling and maintenance, meaning these drawbacks have a limited impact. Okay, that's all of our presentation, and now I will show you the reference list. Okay, that's all from us. Thank you.